Okay, sorry for the interruption. So the area of a path on the surface is approximately the area of a parallelogram on the tangent plane. That's what we decided, right? We approximate the surface with the tangent plane, and so if we want the area of this little curved piece, we flatten it out, and then we can actually compute the area. So how do we find the area of a parallelogram? Okay, so now we just have some plane. Okay, we have some plane. And what is the area of a parallelogram? Do you remember this? Well, the area of a parallelogram is a cross product, right? It's a cross product of, well, there's going to be a vector in this direction and a vector in this direction, but in the tangent plane. Okay, so we have some vector here and some vector here, and the cross product of these two vectors is the area of the little parallelogram that they span. So what are these two vectors? Well, let's look at it. This curve that I'm indicating right here, this was one of these horizontal lines. It was the image of one of the horizontal lines, right? That's where this curve came from. And this curve right here was the image of one of the vertical lines. It became one of these curves. So what is this? This is telling us, this vector tells us how r changes as u changes. So this is r sub u. And this one is r sub v. So the area of this little volume element is ru cross rv. Well, I was a little sloppy, because what we're doing is we're scaling this. That's this gives some vector at this point, but we want to scale it by multiplying it by delta u, by a small change in u that's equivalent to the length of one of these little line segments here. That will be delta u. And similarly, rv is some vector in this direction, but we want to scale it so that we're just talking about this tiny little block. So the area will be the area of this parallelogram. We have to multiply by delta u, delta v. Okay, so now we have the area. This is like an area element, delta a. Okay, and what we know to do is to add up all these areas, right? That's how we do this. So let's write this down. So the total area of the surface will be approximately, so the squiggly equal sign means approximately, it's approximately the sum over all the little blocks. So say the u blocks go from, say there are n blocks in the u direction and m blocks in the v direction, then we want to add up all these little pieces. So this would be, I don't know, some ui and vj, right? So that's this point here is r of ui. This point on the surface is r of ui comma vj. And so what we have here is r u sub I cross r v sub j delta u delta v. And as we know, what we do is, to get the actual area, we take a limit as m and n get very, very large, infinitely large, and then each sum becomes an integral. This is over some region d in the uv plane. Okay, and the integrand is ru as a function of u and v cross rv also as a function of u and v, and then as usual this element delta u, and the limit becomes du, and delta v becomes dv. Okay, so that's it. That is the surface area. That's the surface area formula. Okay, so let's look at a couple examples of this, of using this formula, and I'll put that in the next video.